Hello, so today I'm looking at M3 International A-Level May 2014. This is question 4, and I can see that this is testing me on variable acceleration because they've given me force in terms of time and they're asking questions about speed, distance and energy. So at time t equals 0, a particle p of mass 0.4 is at the origin O, moving with speed 4 along the x-axis in the positive x direction. At time t seconds, t is bigger than 0 and the resultant force acting on the particle p has magnitude this and is directed away from O. So in other words, this is the force working in the positive direction. Show that the speed of p cannot exceed 6 meters per second, and this is worth 5 marks. So here, because they've given me the force, then I can use the formula Newton's second law, that the resultant force, and I'll write this in a way that can be integrated or differentiated easily. The resultant force is equal to the mass, which was 0.4, so that's 2/5. The mass times the acceleration. Now, in these kind of questions, I have a choice of whether to write the acceleration as dv by dt or v dv by dx. And in this case, because they've given me the force in terms of time, then I'm going to write the acceleration as dv by dt, so that then I can find out the relationship between the velocity and the time. And by looking at what happens to my expression for velocity as the time varies, I can work out how to show this. Okay, so I can see I have a 4 and a 2, so I'll divide both sides by 2. And so now I need to separate and integrate, and I'll pop this 5 up here. So 2 times 5 makes 10. And so I have 10 t plus 5 to the negative 2, and this dt will end up on the left hand side, and I put the integral sign, and then on the right hand side I just have 1 dv. Okay, and I'm going to do an indefinite integral rather than a definite integral because I don't have specific values of t to put in or v to put in. So integrating the right hand side, then I get v. Integrating the left hand side, then I add 1 to the power and divide by new power plus c. Okay, now I need to work out what this constant of integration is by putting in some initial values. So I need to look back here, and they did tell me when t is 0, the mass is at the particle is at the origin, so in other words x is 0, moving with speed 4, so I know that v is 4 at that time. So here are my initial conditions that I can pop into here. So when t is 0, then I know that the velocity is 4, so if I pop that in, then I end up with 4 equals c plus, and here I have a negative 10 over 0 plus 5, which is 5, and there was that minus 1 there, so that 5 ends up on the bottom. So I end up with c is 6. Okay, because here I end up with a 2. And so now I'm ready to write what the velocity is by popping my value of c back in here. So I get that the velocity is 6 minus 10 over t plus 5. Okay, so there's my expression, and it's a good idea to write that out clearly for the examiner to get one of the marks, kind of answer marks along the way. Now, the question was actually asking me, though, show that the speed of p cannot exceed 6 meters per second. So I need to think about what will happen as I vary the value of t. Well, when t is 0, then I'll just get 6 minus 2, which makes the 4 that they told me about. When I make t bigger than that, then the denominator will get bigger, which means that the value of this will get smaller, and so therefore I'm always going to be doing 6 take away something, and so v is never going to reach 6. So this depends on the fact that this is always going to be positive. So as 10 over t plus 5 is bigger than 0 for all values of t, v will be less than 6 for all values of t. Okay, so that is part A, that's worth 5 marks. Then part B. So in part B, they give me this information that the particle passes through this particular point A when time is 2 and passes through a point B when the time is 7, and they want the distance. So basically they want the relationship between x and t. So if they want the relationship between x and t, well, I know that v is dx by dt, so I could rewrite this as dx by dt is this thing, and then once again I could separate to give me the relationship between x and t. So if I separate and integrate, okay, now in this particular case, definite integral or indefinite integral, well, here they gave me these 2 specific values of t, and I basically want the difference between the value of x at a and the value of x at b. So I could just essentially say that the value of x is going from 0 to a specific value x, and here the time goes from 2 to 7. And so essentially we're just measuring the displacement from wherever it was when time is 2. Okay, so going along with the maths then I get that x evaluated from 0 to the specific value capital X. Here, when I integrate this, I end up with 6t. When I integrate this, here I get negative 10 natural log of t plus 5. And then I need to evaluate that from 2 to 7. Okay, so popping in, oops. So popping in the value of x and taking away the value of 0 here, I just get x, this displacement that I'm looking for. Here I get 6 times 7, and then I would take away 6 times 2. Then I would subtract 10 natural log of what I get when I put 7 in here, which would be 12. And then I would subtract negative 10, so in other words add 10 natural log and see what happens when I put 2 in there, and so that will give me 7. Okay, very often people put 7 in, write out the whole thing, put 2 in and write out the whole thing. You can do that. There's what you get when you put 7 in, there's what you get when you put 2 in. I prefer to write it in this order because I think it's a bit easier to simplify. So if I have 6 lots of 7 minus 6 lots of 2, or in other words 7 lots of 6 minus 2 lots of 6, I get 5 lots of 6, which is 30. Then here I would get, combining these two, I'm using the rule that I have 10 basically log A minus log B, natural log, and so I would end up with natural log of the one that is positive over the one that is negative. Okay. Now it said find the distance, so I could leave it like that, or it might be nice for the examiner if I pop that into my calculator to help them out so that they can get a distance in meters. So if I type in 30 plus 10 natural log of 7/12, whoops, then I get that this is 24.6, or I could round that to 25 meters, to two significant figures, and that is worth 4 marks. And finally, in part C, I'm asked to find the gain in kinetic energy of P as it moves from A to B. Well, what do I know about A and B? I've got a value of T for A and a value of T for B. And for the kinetic energy, I need the velocity. Well, I do have the velocity in terms of T, so I could work out the velocity at each of those positions. So the gain in kinetic energy will be half times the mass, and I need to do basically the final velocity squared minus the initial velocity squared. And I can use this expression and the values of t is 2 and t is 7 to work out the velocity at each of those points. So when t is 2, the velocity is 6 minus 10 over 2 plus 5, so 7. And when t is 7, then I know that the velocity is 6 minus 10 over 12. So therefore the gain in kinetic energy will be a half times the mass was 2/5, times by this squared minus this squared, no sorry, the gain in kinetic energy, yep, so the final one squared minus the initial one squared. So if I do 6 minus 10 over 12, then I get the speed at the end, which is 31 over 6, so I need to square that. And I'm just going to store that in my memory and make a note that I pop that in my memory A. If I work out the initial speed, that was 6 minus 10 over 7, and that gives me 32 over 7. And I'll just make a note to myself that I will store that one in B. Okay, so I'm doing the final speed squared minus the initial speed squared. So for where I put them in the calculator, I'll do A squared minus B squared. That gives me the change, this change here, and here those twos cancel, so I just need to divide that by 5, and that will give me the change in kinetic energy of 1.2 joules. Okay, that part of the question was worth 3 marks. I hope you find that helpful.